On November 29, 2015, a flash fire occurred at a refinery's sulfuric acid alkylation unit, causing severe burns to one operator. This incident happened during the preparation of equipment for maintenance, where leaking hydrocarbons ignited, resulting in injuries, equipment damage, and a fire that burned for an hour before being extinguished. What happened? The alkylation unit was being prepared for maintenance. Operators planned to drain and isolate vessels connected to a caustic settler and coalescer. A leaking block valve failed to fully isolate hydrocarbons in the depropanizer column from the vessels. At 6 p.m., night shift operator, unaware of the backflow of hydrocarbons, opened a drain valve, expecting only water to flow into the oily water sewer, OWS. A vapor cloud of highly flammable isobutane ignited, likely from a furnace 120 feet away. The resulting flash fire injured the operator and caused fires along the OWS drains, requiring emergency response efforts to isolate the fuel source. What are the root causes? Inadequate isolation, a single block valve, later found to be leaking, was relied upon to isolate hazardous hydrocarbons. Lack of procedures, the refinery lacked a standard procedure for safely preparing the caustic settler and coalescer for maintenance. Informal instructions created by operators failed to assess all risks. Missed hazard identification, no process or risk assessment was conducted to evaluate hazards introduced by the leaking valve or the expanded isolation plan. Design flaws, hazardous materials were drained into the OWS system, which was not designed to handle flammable hydrocarbons near ignition sources like the furnace. Key lessons and recommendations. Enhance isolation methods, avoid relying on single block valves. Use double block and bleed systems, blinds, or complete disconnections for hazardous energy isolation. Develop standard procedures, create clear, documented processes for all equipment preparation tasks, including decontamination and isolation. Conduct hazard assessments, use pre-planning and risk assessments to identify and mitigate risks during non-routine tasks. Improve energy dissipation, route hazardous materials to closed systems like flares or scrubbers, rather than to OWS systems near ignition sources. Implement a change management system, apply management of change (MOSI) reviews to evaluate and control risks when modifying or expanding isolation plans. Thank you for watching.